This question is about the nuclear radius, and there are a couple of ways of doing it. You could do it from the perspective that, and you're given this in the formula and data book, that r equals r naught a to the third, and you could look at it that it is the cube root of the mass number. So it's related to the cube root of the mass number. So the ratio of the cube root of 238 to the ratio of the cube root of 12 should give you the same ratio of nuclear radii of these two things. That's one way of doing it. My only hesitation with that would be that it might be quite easy to make a mistake where if you've got time, you're probably better off working this out in a slightly different way where it's clearer exactly what you're doing. And that way for me would be to find out what R naught is. So getting a value of R naught using the value you've been given for uranium. So the value for uranium is given to us, and then R naught is going to be R over A to the third. And we're given that for uranium is that it's 7.75 times 10 to the negative 15 all over the cube root of 238. And it could be that you don't often do the cube root. If that's the case, then a bit of practice would be a very good idea. So we've got 7.75 times 10 to the negative 15, all divided by the cube root of 238. Taking me a little bit longer because it's not a function I do very often, and I should practice using this calculator a little bit more. And we end up with R being equal to 1.2505 and some other stuff times 10 to the negative 15. Okay, not finished yet. And we're not given that as an answer, so we wouldn't get caught out if we hadn't spotted that. And then we're looking for what's R for carbon 12. Well, it's this 1.2505, etc., multiplied by 12, because it's the mass number of the carbon nucleus, to the third. It's the cube root of 12. So multiply that by the cube root of 12, and I get that it's 2.86 times 10 to the negative 15 meters.